Okay, there's been some complaints that I don't have a tripod. Well, I'm sorry. I have to do this by hand, at least for now. Um, anyway, thank you, everyone, for your comments. I really appreciate it. And tonight, what I'm going to do is basically show the RF out on the phono plug and show at 7 megahertz on the spectrum analyzer. This is already tuned to the 40 meter band, basically 7 megahertz, as you can tell. First thing I'm going to show is the ALC is disconnected right now. I have it tuned to basically full power. First, I'm going to show what kind of power I'm getting. Basically almost 100 watts. Now I'm going to connect the ALC. Now I know I've done this before, but I'm just trying to reiterate here real quickly. Right now the ALC is connected. This is what I get. About 10 watts. Now I'm going to, I'll just leave the ALC connected. This, by the way, is with obviously all the tubes lit, or I wouldn't be getting any power. I don't know why I had to say that, but I said it anyway. So this is the spectrum analyzer here. I already went out to about 100 megahertz. This analyzer goes to 1.8 gigahertz. There's really nothing out there. So I zoomed in on basically start 0 hertz, stop is 20 megahertz. The resolution bandwidth is 100 kilohertz. So again, I'm sorry not having a tripod. I'm doing the best I can with a handheld telephone here. Anyway, this is 40 meter, fully powered up. This is with the ALC connected. And I'm going to stop the trace as soon as it comes on so we can analyze it a little bit. Okay, that's basically what we're getting. We'll stop the trace. Let's see, do a peak search. It shows 6.35 megahertz. As I said, I don't have a counterlock board for this spectrum analyzer. I did put it on my 12-digit frequency counter, and it is 7 megahertz, so don't worry about that. The frequency is correct. And as you can tell, it's pretty much clean. That's with the ALC connected. Okay, so what we're going to do is we're going to take the ALC off and disconnect it and reset everything. Start the trace back again. All right, and I'll try to hold this as steady as I can. Again, I apologize for that. Now, this is with the ALC on. You can tell we do have a higher harmonic, but we also have a higher signal as well. So I don't know if that means anything or if it doesn't mean anything, but that's what I'm getting. And that basically it looks like a harmonic to me. If we do a peak search, we go one to the right, that's 13.45 megahertz, and the other one is 6.35. So, it looks like a harmonic to me. That's what I'm getting. I don't know where else to go from here. I did use, that's my brand new function generator right there. I cleaned it up, and although it's not calibrated perfectly, it is pretty much in line. The amplitude calibration needs to be done on it. But it does work well enough that I put a sine wave through here. I basically disconnected that white and I think it's a blue wire there on pin 6, which goes to the driver tube. And I ran a sine wave through it, and the ALC was still kicking in. So I really don't know what the hell is wrong with this damn thing. Anyway, if you all want any other tests, please let me know. Again, I apologize for not doing certain tests. I didn't know what you all wanted or what you didn't want. And again, thanks for helping me. this is a very tough problem. I have actually found, and I'll try to put on the forum, some other people complaining about the exact same thing. One was on the island of Misfit Hams. There was a post, and I think I did that already, of a similar problem. In fact, it was the exact same problem. And there's also another post on Fox Tango, if I'm not mistaken, but no one has ever posted a solution. So I don't know, but this is actually sniffing off of the RF coming. This is going right into the driver. You can tell the wounded, the induction line right there. This is not a direct connection to the spectrum analyzer. The frequency looks good. I am getting that one harmonic there, which is higher with the ACL on, but even with the power amplifier tubes turned off, in other words, their filament's not lit, I can still tell by looking at the meter with the ALC switch engaged that attenuation is taking place, even with the tubes not lit. So I don't know. There has been a suggestion for me to tap off of one of the diodes, which is from rectifier A, to look at the ALC, what kind of signal is basically being rectified. I've done that already. And basically what I get is no signal at all on the other bands. And it's strange because I get almost no, well, I take that back. On 160 and 80, I get a small signal, but not enough to attenuate much. On 20, I get nothing. I mean, no matter how hard I drive it, I get no signal whatsoever. And this is before the rectification takes place. I get hardly anything. On 40, I get a very large signal comparatively, relative to the other signals that I was just talking about. It is the same frequency as the driver signal. So, if it's 7 megahertz, well, then the signal would be 7 megahertz. It's not a harmonic. It's actually that signal. And it's strongest at 40. It's then rectified, of course, and becomes the strongest DC signal. So, yes, it all follows, except why is it so strong on 40 meter? I originally thought it was a resonance problem, and that has actually been suggested. I've changed some of the capacitors. I've checked them with an LCR meter. They were not bad. The big one that I changed is there's a coupling cap, which is a silver mica cap, which I thought might be bad. That was changed to another silver mica cap, brand new. Didn't make any difference. And the ALC circuit is not that complicated. I checked the diodes as well. I've checked all of that. I appreciate you all, your input, but I have checked that and I have looked. And in response, yes, I am getting a signal there. And it follows. The signal there is a waveform, a sine wave, which is at the same frequency as the major sine wave, which is being broadcast. Well, broadcast, I mean, coming out of the antenna port or the RF phono port, and it is highest on the 40 meter band, which then it's rectified and of course gives you the highest negative DC bias, which is then fed into the noise blocker unit to one of the gates of the MOSFET, which attenuates the signal. All of that is the way it should be. It's attenuating it, as you all saw, so much that with it disconnected, I'm getting 100 watts. With it connected, I'm getting under 10 watts. And on 20 meter, I'm getting no ALC offset at all. On 80, a little bit, but not enough to really make any difference. On 160, the same way. On 15, a little bit. It's almost like on the 40 meter band that it's resonant, but there's no reason why it should be resonant. Anyway, there's something I'm missing here. There's something very simple probably that I'm doing wrong. I hope you all stick with me, and any suggestions, let me know, and we'll take it from there. Anyway, thank you all very much.